In this class, you have to do hands-on projects, and the first group of hands-on projects is Splunk, which is very easy and fun because you don't have to install anything. And so you go here, here are the instructions, and I'll get rid of this extra scoreboard there. I'll show you where the scoreboard to use is. But let me just, anyway, once you go here, there's two running servers. They should both be up now. Let me try the first one. These servers will ask you for a name and password, which is student1, student1. It's not intended to be secure, but what it does is it stops automated attacks, which would bring down my server all the time otherwise. So once you're in, you now have access to Splunk. And this warning is because the data is very old, and the only way I could find to get Splunk to accept old data was to change the clock on the server back a few years. So it works, it just gives you a couple of strange warnings. So we're always going to work here. This is the raw search page, and you see there's about 1 million events. What Splunk is Google for log data. This is all the log data, but this data was made by Splunk employees. They set up a network with a series of servers just like a company, and then they ran a bunch of attacks against it, and they recorded all that evidence so you can practice finding it. So you can search here. Now, right now, by default, it only searches the last 24 hours, but all this data is 9 years old. So you have to use all time, and you can get a data summary here that shows you the type of data available. And you'll see there's Windows event logs, there's FortiGate firewall events, there's sysmon logs, which are just another more useful kind of Windows log. And then there's stream data from the network summarizing the network traffic like DNS, DHCP, and HTTP. And then there's suricata logs, which are intrusion detection. It's an intrusion detection system that recognizes threats on the wire. So I'll just start from the beginning in case people didn't see the previous server. You have to kind of get there anyway. Now, Splunk likes you to index your data, so you break it into categories. In this case, there's only one index, only one group of data. It is called bots v1 for boss of the SOC version 1. So if I search here, it found 124 events, but no more. That's because this is just somebody has turned on some modern logging. By the way, everybody is always logged in as administrator on this server. That's what they do when you have the free version. That's how they stop you from using the free version in production. So students can foul it up, and they do. So I have to restore it from backup now and then. But what I want to do is do all time. And when I do that, I'm going to find 1 million events. So I'm going to sample just 1 in 1,000 to make it faster. The speed of it depends on how many things it finds. So if you have too many events, you do sampling. Okay, so instead of finding 900,000, I found 900 events, 921, and here they are. Now, if I want to see the HTTP events, I can go down here, and I can go to source type, and it will show me the source types that are there. And here's the stream TCP, and if I go to rare values, I see okay, that's not quite as useful as I hoped it would be. I'm going to go back. By the way, if you do go anywhere funny, you can use back in your browser to get back where you were. So what I want is HTTP, so I'm going to take this just to get the right format. And then, instead of TCP, I'm just going to change that to HTTP. So you could be typing in your queries up here, if you know how to do it, but it's better to use the mouse and click on things so it sets it up correctly for you. So HTTP is the protocol I want. I want to see web traffic. And now I only have 21 events, but I'm only looking at 1/1000th of them. So I can take away the filter, and I'll see all the HTTP events in the data, of which there are, I think, 19,000 or something like that. And so, if I do that, it's done. 23,000 and change events. These are log events, and if you look down here, you can see this log event line by line. So here's the IP address, the client IP, there's going to be a server IP. Here's some kind of content, some kind of Microsoft file was moved. If you just scroll down here and look at it, here's a GET request to get a certificate revocation list from code signing. Looks like aspect of making some kind of secure connection. Not too exciting. Let's go down here and see what else we have. Here's a similar one. Here's one. It loaded some web page that was not modified. Now notice this. Hardware compatibility. Okay, looks like another common request. And I'll just look and see, because often you can see immediately a malicious request. Now, in this case, the company's web server is called I'mReallyNotBatman.com, because there was a Batman movie they based this scenario on. So, yeah, Batman.com. I think that's it. Let me check my instructions. HTTP, there, I'mReallyNotBatman.com. I think I got it right. Okay. So now, if I add that to the query, this is what Splunk doesn't like you to do. What Splunk likes you to do is this, name equals value, because that's indexed and that runs really fast. But you can also just put a word here, and then it works like Google. It will find an event that contains that word. They also call this a grep search, because the unit command grep does it. And it takes more CPU time, but I don't care. It gets the job done. So this will find events that contain that domain name, and therefore they're requests for our server. And so I'll let it run and find them all, because there aren't that many. There must be some number less than 29,000 of them. All right, so it's done. There's 22,200 of those. And if I look at these, notice right here, this is what I thought. You'll usually very quickly find attack traffic. If you look at this, this is not a normal request. They're looking select 0 from select sleep, select 0. If you have been taking the pen testing classes, you should recognize this. This is an attempt to perform SQL injection. Selecting something from a database. This is not a normal request. This is attack traffic. So somebody is sending attacks to the server, so this is worth looking at. And you'll see in the HTTP request headers, you'll usually see that it's coming from a, this is a server. And let's see, I expected to see the name of the vulnerability scanner here. Let's see, maybe I should try another event. Yeah, that's what I wanted to see. Here's another attack phrase. You can see, and if you go down here, you'll see Acunetics Scanning Agreement. They used this commercial product, the Acunetics Vulnerability Scanner, and scanned the website. And that means it sends thousands of requests trying all kinds of different attacks. And if you don't modify it, it marks them all deliberately with this mark, because then they're not trying to be a real hacking tool. They assume it's your own team scanning the server, and you'll want to know these events are not an attack. They're a scanner. So now we know what happened. They used this scanner to attack the server to find vulnerability, and we know several interesting facts here that we're going to need. Let me make some room here. So we know it's an Acunetics scanner, and we know this is the source of the scanning IP address, the source of that stuff. And the destination is the IP address of the web server, so we know that too. And these are things that we'll need to know to go forward. All right, so that's the web server. All right, and now that's the first several flags. So if you go here, the scanner name is here. For example, Acunetics is the first answer. That's 1.1. And you turn those in here on the instant response page. Now you could take a screenshot. That's what this explains. You can turn these things in inside Canvas if you want to. Now I don't use the City College Canvas server because they don't maintain it properly. I use my own Canvas server, which you'll find here in the quizzes section. So you can turn these screenshots in with the flags one by one there if you want to, or you can use an automated grading system, which is a capture the flag system, which is what I recommend. That is the way people do everything in this business. And so you'll find here at the bottom of this page a place where you can submit flags. So that one was bots v111. You'll find, if you're a pre-registered student, you'll find the last 4 digits of your student ID here. If not, you can register a new user here with any name you like. And then so I'll choose, there should be a test. I'll register a new one on this one called test then. Thought I'd already done this, but if not, test name, test ID, and no class. All right, now I should have that as an option here. If I refresh the page, yeah, now I have test. Okay, so I'll use that and put in the Acunetics, and it's correct. So now I'll have some points. If you go here and look at the scoreboard, there I am, test has some points. So this is how you get points. Holy cow, somebody's already working ahead here. Anyway, all right, so that's how you enter flags to get your points. If you want to do it this way, you can also send them into Canvas, and my grader will grade them that way. So the first several flags are already defined. It was the scanner name, the attacker IP, and the web server IP. I found all of them from that one event. Now there was a defacement file name. The attackers put an insulting image on the website. And the way to find that is to find traffic that goes backwards through the network. So if you go up to here and look at HTTP data, if you look at the source IP, which I can use client IP, see there's a couple of different client IPs here. So if I click that, that will add it to the query with the right format. All right, and the question is, did the web server make outgoing connections to another server? This should never be allowed. Your server should be a server and not a client. There's two good reasons for that. In the first case, you don't want people opening a browser on the server and downloading stuff because they might infect it. If you want to put a file on the server, you download it somewhere else, scan it for viruses, and then move it over with a shared folder or something. That's the right way to do it. The other more important reason is attackers typically make a reverse shell. If you take the pen testing classes, you'll find this is the most common attack. You run malware on a server, and it makes an outgoing connection to a command and control server, and you don't want to allow that. Your server should not be allowed to make any outgoing connections. It should only take incoming requests and respond to them. So we're going to see if traffic went backwards through the network by putting in the web server's IP address as the source. This should never happen. Your firewalls and routers should be configured to block this. But if they aren't, it might happen that the web server makes an outgoing connection. Now, if I run this query, I'm going to get 0 events. I'll wait till it finishes, and I see the check mark. Okay, I get 0 events, and I'm not sampling. That's because I left the domain name in here. If it makes an outgoing request, it would be going to some different domain name, not this server's domain name. So I have to get that out of here. Now, if I run this request, or this search, I'll find some events that went backwards through the network, 9 of them. And there's such a short number, you can just look through them, and you'll see what they did. If you go down here, this is binary data, all this backslash stuff. And if you go down here, you'll see the request that led to it. And there it is. Here's the name of the image that was loaded. Poison Ivy is coming for you, batman.jpg. And here's the server it came from, prankglassine_bracket.jumpingcrab:1337, a very suspicious name on an unusual port. So this is what's a staging server that the bad guys had. They've got a server here where they're hosting a malicious image, and the name of the image is this thing here. Poison Ivy is coming for you, batman.jpg, and there's a few more flags. So this is what you do. You use it to analyze the various kinds of attacks here. And so now we found the staging server IP. We can use a search engine. We need to find the IP. So this event here, I found it went here. I should find the IP address of this event. And there it is, destination IP. This is the IP address of that prank glassine bracket domain. So I'm learning quite a lot about the bad guys. I now know 2 of their malicious servers, one starting with 40 and one starting with 23. I know a domain name they used. I know an image they used. By the way, this is what you usually find. I'm now in the middle of the attack. I found an insulting image, and I found that they managed to put it on the server. But I don't know how this is possible. They somehow gained code execution on my server, and I haven't got to the bottom of that. This is what you usually have when you're doing an investigation. You find out something in the middle. And now you have to say, well, how did they get control of the server? And that, I think, is the next thing we're going to do here. Yeah, the brute force attack. So here's how they got in the server. We're going to get the events using the post method. So let's go to here. I want HTTP events. Okay, I've got some here. Now, if I look down here for HTTP method, there it is. These are all gets, but I want posts. So I'm going to click this just to get the format correct up here. And I'm going to change that to post. And I'm going to get rid of this restriction on the client IP because I want requests going to the web server. So, in fact, I probably should put the domain name back in here. That's how I get requests going to my server using the post method, using HTTP. So these are, because post requests are login requests typically. They can be other things, but login requests are almost always post requests. And so, according to my notes, you should find 15,570. Okay, looks like I'm off by 10, but that's good enough. 15,560. I found a lot of post requests. Now, I want to exclude the events from the vulnerability scanner. So the way to do that, just like you would in Google, you can say not, and then Acunetics. And that is, again, one of these grep queries. It will just not allow that word to be anywhere in the event. So that I had 15,000, but most of them came from the vulnerability scanner. And now I only have 431 left. So now that I have those, I want to look at the form data. And an easy way to do that is to make a table with time and form data by adding this to the query. So I put that in there. And now I'm not going to get all the information. I'm just going to get this one field, form data. And so these aren't very interesting. What I'm going to do is sort by time. And this is now going forward in time, 21.22, 21.24. Okay. And now you can see many requests, all for username equals admin with different passwords. 1, 2, 3, 4, 5, 6, 7, 8. Password is let me in. Password is QWERTY. This is an automated brute force attack. It's running a script, trying many guesses per second, going through a whole list of possible passwords. And if you follow it, it has many pages here of this. If I sort and look at the end of this, I'll see at the end there are a bunch of things that are not part of this attack. So that's annoying. I need to somehow get rid of the extra events. So I go back to the start, sort the other way. Whoops. I've hit the wrong thing somehow. 431 events. I think it's statistics. There we are. I want to sort with here, time. There we are. I noticed the ones I want have this in them. Username equals admin. That was the account they brute forced. So I'm just going to add that here as a criteria. So I only see the events that are part of this brute force attack and not other random post events. Now I'm down to 413 events, and I can see this. Let me sort by time again. Okay, here it is going forward in time, many guesses per second. All these are at 21.2 seconds. So here's the script running. So it runs trying hundreds and hundreds of events, and then at the end, you'll see it tries all these passwords very quickly, 50.8, 51.1, 51.3. Then there's a gap from 46 to 48 minutes. What happened is it ran a script trying hundreds of events, hundreds of guesses, and it found the right one. And then the attacker logged in by hand from a browser using that password. And that's why the structure of this is different. The password is right there instead of the password being over here. And so that's the brute force attack, those events going up to this time. This is the manual login by a human who will now execute commands on the server. And there's another way to see it. If you go back and look at the raw events here, and then look at the HTTP user agent, which is here, you'll see there were 412 events from Python and 1 from a real browser, Mozilla. So that's the script, a Python script running, trying hundreds of guesses, and then eventually it found the right password. Then the attacker came in here. And if you look at the source IP address, which I think will show up as client IP or, yeah, client IP, you can see the script was run from this machine and the attacker logged in from that machine. So this is the one they're using for interactive work. This is the one they're running scripts on, and this is quite common. So we now know a lot about how they got in. They've made a brute force attack on the administration panel until they got the administration panel. Once they had the administration panel of our content management system, which I think is Joomla, they were able to upload a file and execute it and deface the server. And if you go down here, you can find the name of the uploaded executable file name. So we start with these same events, use the post method, and then we look for an executable file name extension. So all we have to do is keep all that and then put like .exe here. And you'll find only 2 events. And those will contain the name of the file that was uploaded. And in fact, the easiest thing to do is use the browser now with Control F and search for .exe. And there it is, 3791.exe. And this is very common. If you go to, there's online repositories. If you take the pen testing class, you'll learn this. There's online repositories of attacks for all the known vulnerabilities. So this is a common procedure. You run a vulnerability scanner, you find a vulnerability that's known, then you just go to a list of known attacks and you run a known file. And those are usually have a name like this, just a number.exe for all the vulnerabilities. So these guys are just using standard pen testing techniques. If there's an old version of something running with a known vulnerability, then there's probably a known attack file that will just give you something like a reverse shell or take some other action. And that's what happened here. So you can now answer a lot of these questions here. And I think that's all I wanted to show you today. That gets us up to 11:30. And I should also mention, this is what I'm going to do. It's a 3-hour class, but I only use the first hour and a half for normal stuff, and then I answer questions. And you can come to any of these with questions from any class. So if you get stuck on anything, I'm here Saturday at 11:30 and Monday through Thursday at 7:30 p.m. I'm online, and you can either come physically to the classroom where I am, or you can connect online with Twitch and ask any questions. So as you're working on stuff, if you get stuck, there's a lot of opportunities to get help. Especially if you have, some administrative problem, like you can't add, you can't make an account on the server, you can't find the instructions, all that kind of thing. Contact me. That's by far the best way. And email is not very good. It tends to pile up. The best thing is come to the Twitch sessions. Then I can help you. All right. So that's what I wanted to show you. Let me check for questions in the Twitch. Nothing new. Okay, I'm going to stop this recording.